Okay, happy day and welcome. So we're on part 2 of the mole conversion notes. So we already went through this first part where we were talking about what the mole is and then how do you figure out the mass of a sample. And so I was explaining that you're going to be given these numbers, so you don't actually have to add them up, which is kind of nice, but still good to know. Okay, so let's start off with our problem solving technique. Okay, so remember everybody's going to say this with me. So the circle what you want, write what you got, throw in a bridge, and cross your units opposite. Here we go, ready? Circle what you want, write what you got, throw in a bridge, and cross your units opposite. Okay, now remember the opposite is not to the side, it's actually diagonal, okay? You need to remember this. And please don't try to shortcut it. I've seen way too many people try to shortcut it. You just make mistakes, and then you're guessing, okay? So I don't want to guess. I want to make sure that you do that. Yes, it's going to take a couple extra letters. You have to write a few extra letters, but how long does it take you to write a word that's like 6 letters? It doesn't take you long, right? So yes, it's a little bit of writing, but not a big deal. It's not like you're writing a paper, okay? So in the lab, we don't measure substances using moles. There is no molimeter. That doesn't exist. Instead, we typically measure the mass or volume of substances. How can we convert from one to another if we start with the mass of a substance? So a lot of times what ends up happening is we want to try to figure out, we say, okay, if I'm starting with this many grams, let's say I'm making liters of a gas. So I want to know how many liters of gas I can produce. How do we do those conversions, okay? And so sometimes it's grams to moles, sometimes it's moles to liters. So I'm going to explain this in just a second. So we're going to use these conversion ratios. And so that is going to help us to convert from one to another. So I need to explain this. The problems that we had done before, we're going from moles to moles, and we are actually switching our substance. What we're going to start doing now is we're going to start doing problems where it's the same substance also, but we just want to switch from grams to moles, or I have to switch from grams to moles and then switch to another substance. So the problems are going to get a little bit more involved now, okay? So question 1, you already know how to do this. I'm going to set a timer right now. I'm saying 1 minute. What I want you to do is circle what you want, write what you've got, throw in a bridge, and cross units opposite, and let's see how you do with Q1. Do this in under 20 seconds here. Circle what you want, write what you've got, 7.26 moles of H2, throw in a bridge, cross your units opposite. Look for what I'm trying to find, and that's mole of NH3. And then remember, we get these numbers not from here. Do not cross this number opposite. We're getting it from our bridge. Or for my ratios, I've got 2 with the NH3, and I've got a 3 with the H2. And so all I'm going to do in my calculator now is 7.26 times 2 divided by 3, and I get 4.84. I like 3 digits. Remember, these cancel out, and I'm left with mole of NH3, and then we're going to box that in, okay? All right, so hopefully you got that right on this one. Okay, so now what we're going to do is all of the problems that are going to come next are going to be the same substance. So you're going to notice I didn't even give you a balanced equation. So basically what's going to happen here, so let me take you to this double roadmap. Okay. So everybody has a double roadmap, should have a double roadmap in front of them. This is what we use in honors. Okay, so if you take honors next year or the year after, they have to do a lot of different conversions. Okay. In our class, we're just focusing on 2 things, okay? One is, can you get from mole to mole? That's going to be 1, is getting from mole to mole. We already did that. And all you have to do is use a mole bridge. How do we do it? Remember, we use the coefficients. So we say mole A, and A, by the way, is what you started with. It could be a product or a reactant. Sometimes A, they'll say, you made this much water. You produced 2.5 moles of water. How many moles of carbon dioxide reacted, for example, okay, or whatever it is. So what you want to do is, that's your A. Whatever you're starting with in your bridge is going to be your A, okay? So it could be a product. Keep that in mind. The only part we're going to do is we're going to do grams, but we might have to go to grams. That's going to be a challenge problem, okay? So we could go grams to moles to moles. And the way that this thing works is, who's ever been in a city where they had a subway system? Who's ever been in a city with a subway system? Okay. So if you've ever had to deal with the maps, they're very interesting, okay? But it's like you could take the yellow line and you could take the red line, and then there's usually like some station that's kind of like a grand central station where all of the lines tend to meet, okay? And so you kind of have to figure out where you're going and how to get through that line. So the way that this is going to work is if you're staying within one city, so let's say that within the city, there's a park I want to go to, there's a restaurant I want to go to, there's some movie I want to go see at some theater, but then I need to cross over into another city. If I need to cross over into another city, now I need to take my mole bridge to get over to the other city. In other words, if I'm going from one substance to a second substance, I need my mole bridge. If you're not switching substances and you're staying within that city, in other words, my substance is staying the same, it's sodium chloride. It's still sodium chloride. You say, if I have this many grams, how many liters is it? Or how many molecules do I have? And again, we're not going to do liters or molecules or like atoms or ions. We're specifically going to be doing grams and moles. Okay, that's going to be our major focus for doing our bridges. Okay, so we can stay within one city or we can cross over to another city. All right, so let's take a look and see. And I always, in the beginning, I like to map it out just to make sure that you're seeing it. You're seeing the big picture of like, where are we going? Where are we starting and where are we going? Okay. So let's come back over here. All right. So this question says, what is the mass in grams of 0.682 moles of magnesium? How do we start a problem always, everybody? Circle what you want. Circle what you want. So we know we're looking for the mass in grams. Write what you've got, right? So 0.682 mole, leave out the of, and just write MGS. But please make sure you write the MGS, okay? I know you're going to start like wanting to leave it out. Just do it, okay? Throw in a bridge. Cross your units opposite. Remember, it's everything but the number. Do not cross this number over, okay? So now, I'm going to take a look at my, I call it the switch it thing or the double road map. And I want to see where are we and where are we going. They're asking us for the mass of the MGS. So in other words, are we switching cities? Using my analogy, are we moving cities at all? No. How do you know? Why are you saying no? You're right. Why? Why not? It's only one substance. It's MGS and it's still MGS. That means I am not going to use my bridge. There's no bridge, no need for a bridge, okay? Where are we starting? Where's our starting point? Well, they're asking us for grams. Where's our starting point, though? Moles. We're starting here, and we're going down this way to grams. Don't worry about this because you're, based on you crossing opposite, it's going to tell you what goes on the bottom. Because people will always say, Ms. Ismail, I'm so confused. I don't know what goes on top and what goes on the bottom. It depends on what you crossed opposite, okay? So let's go back over here, and let's take a look. So I know I'm going to grams in this case, and this could be flipped. Anybody want to guess what number goes with the gram? I see people about to say it. 56.4, very good. You can see here that there's 56.4 grams is equal to what? 1 mole. Okay, now again, this could be flipped, but just like 12 inches in 1 foot, you cannot say 12 feet in 1 inch. So the number has to match with the unit, okay? But it doesn't matter on what's on top and what's on the bottom. We're done. So all I'm going to do is cross this off. These are pretty quick. These are also under a minute problems, okay? It's only a one-step problem. What do you think you're doing in your calculator? You just multiply. We ignore the ones, right? We ignore the ones. We would divide if we needed to, so we'll see how the next one works. So we're going to do 0.682 times 56.4. And we get, I want 3 numbers. So the answer I get is 38.4648. People getting that too? Okay. So if I want that rounded to 3 digits, what does this become on the count of 3? What do you think? 1, 2, 3, go. 38.5. Very good. 38.5. And now I have grams of the MGS. Okay. So I just switched from moles into grams, okay, of the MGS. All right. Let's try this one now. So now circle what you want, write what you've got, 12.5 grams of the LIF, throw in a bridge, and cross your units opposite. Okay, so now we've got our units opposite. So now take a look on the map. Let's see, where are we and where are we going? So where are we starting now? We're starting with, what are we starting with? Grams. What are we trying to get to? Moles. So let's take a look at our map. We're starting here at grams, and we're trying to go to moles. Again, if you want to, you can use this, but my recommendation is just see what you crossed opposite, and then you're going to know, okay? So I know I'm using the periodic table to find the molar mass. Again, I'm going to give it to you. Okay, So that's grams. Oh, that's an F. Just make sure that looks like an F here. This is LIF. Okay. So what's going to go on top must be the mole. Okay, on the count of 3, what number goes with the mole, everybody? 1, 2, 3. What number goes with the mole? I heard like 2 people. Ready? What number goes with the mole? 1, 2, 3. 1. Look it. 1 goes with the mole. So the 1 goes with the mole. So then what number goes with the gram? 1, 2, 3. 26.0. Very nice. Okay, so now in your calculator, ignore the 1, right? Now in your calculator, what do? 12.5 divided by 26. Good. Everybody say denominator divide. Denominator divide. If it's in the denominator, you have to divide. So we're going to do 12.5 divided by 26. And I'm getting 0.480769 something, something, something. Okay, 3 digits. On the count of 3, what would your answer be? 1, 2, 3, go. 0.481. Very good. 0.481 would be 3 digits because that 7 is going to round the 0 up to a 1. And then our grams canceled out, and we are left with moles of LIF. Okay, so now we've got an OYO, so we're going to skip the OYO for a second here, and this one's also an OYO, so you're going to come back and do those, but you're going to mimic what we did when you go to do your OYO, okay? All right, let's flip over to the back. So again, we've got our how we problem solve, right? We already know that. Okay, so this one's an OYO, so we're going to skip the OYO. This is similar to, this is just mole to mole, okay? So just to make sure that you're aware of this, if you're on your double road map, you can see if you're starting with moles and you want to end with moles, anybody want to tell me what do I need to do? Go through what? The mole bridge. Very good. I am switching cities now. So if you take a look at this problem here, you can see I'm starting with FeOH3, but I'm ending with H2O. So if your substance changes, you have to use the mole bridge every single time, okay? So that's when you're going to go back and use your ratio, okay? All right, so now we're going to be on multi-step problems, okay? So these, I say double your time. So instead of 1 minute, it could take 2 minutes to do a double step problem. So same thing, circle what you want, write what you've got, throw in a bridge, and cross your units opposite. Okay, so go for that. Grams of FeOH3. Again, you're going to get annoyed by how much writing there is, but it's really not like you're writing a paper. Okay, so I just want you to keep thinking of that. It's not that many letters or numbers. Okay, so I'm going to take a look because I want to map this out. What I mean by map it out is take a look at where are you starting and where are you ending. Where are we starting? Grams of this FeOH3. Where are we ending? Moles of H2O. So we are switching our substance, so keep that in mind. So let's take a look at our map, and let's see where are we starting, where are we ending. So I'm starting with substance A, and I'm down here at grams. Where I want to get to is where? Who knows where we want to get? To moles of what? Of substance B. We actually want to get here, because it's a different substance. So in order to do that, where do I need to go first? To moles here. Very good. So I first need to go this way, and I'm going to use the periodic table number to go this way. Then where do I go? Now I'm going to go across using my mole bridge. Okay, and then I should be there. So you always want to plot it out. You always want to check to see where, sometimes you're starting here and you're going to grams there. If you're in like what we do in honors, you could be starting at liters and going to grams. And so you'd have to like come down here, go across here, and then come back the other way. Okay. Sometimes it's a 3-step, which is going to be a challenge problem for us. I am going to have you try that one, where you have to start at grams and end at grams. And if that's the case, what would you do? If you had to start at grams and end it with grams of a different substance, what would you have to do? First what? First go to moles, then what? Cross the bridge, and then what? Go back to grams. Okay? So you're going to use this to try to guide you, all right? Okay, so we know the first thing we need to do, we said, was go to moles. Okay, so first we need to go to moles. I have not switched my substance. I'm not out of the city yet. So that means that this is still, and I do want you to write this, otherwise you're going to be confused, okay? You're not going to know what number goes where. Okay, so I need to relate grams and moles. What do you guys see? What number goes with the mole? 1, 2, 3, go. 1. It's right here. The 1 goes with the mole. And then how many grams are equal to that? 1, 2, 3? 106.9. 106.9 is what's going to go down here. Okay. So my grams are gone, by the way, but now I'm in moles. I don't want moles of FeOH3. I want moles of H2O. So continue your bridge. I do not want 2 separate bridges or 3 separate bridges. I only want 1. The other thing I want to remind you of is I do not want you writing anything besides the answer down after you're done. Okay? I don't want you, what people will do is they'll multiply the top line, they'll multiply the bottom line, they'll get their answers, and then they'll divide. All you're doing is causing a situation where you may run into more errors, okay? The more you write, the more errors you can have in that situation, okay? So let's write mole of FeOH3 down here. Why? What happens when they're opposite of each other? You can cross them out. So that's my plan, okay? I want to be able to cross them out. Not yet. So we said that we got here now. Now I need to cross my bridge. How do I cross the bridge? What do I need to do? What goes on top? What goes on top, though? What goes on top? Moles of substance B. Moles of substance B are going to go on top. I'm going to use the coefficients. Very good. I'm going to use the coefficients. So what is substance B? That's what I'm trying to get, which is H2O. Okay, so what we need to come up to our balanced equation. Remember, that's when we use our balanced equation. On the count of 3, what are my numbers for H2O and FeOH3? So what's something over something? 1, 2, 3, go. 3 over 2. Very good. I see the 3 here for the water. I see the 2 here for the FeOH3. I'm done. That's a 2-step problem. Okay? So now, in your calculator, multiply before you divide unless you're going to hit equals every time. Okay? So what I want you to do is I actually want you to go across your numerators, leave out the 1, right? So we're going to do 53 times 3, and then I want you to divide. I'm going to walk around. Please don't clear your calculator. I want to make sure that you get the correct answer in your calculator. What you should get, do not delete it, is 0.74368 something something, okay? Let's round it first. If I want this to be 3 digits, 1, 2, 3, go. 0.744. Very good. 0.744, and this would be moles of H2O. Okay, let me pause because I'm going to walk around and make sure everybody has the right answer here. Okay, last one. So let's try this last one. Let's see how we do, and then I just want to explain one more thing just to make sure that you have a good idea. Okay, so circle what you want, write what you've got. If you feel like you know what you're doing, you might want to just go ahead and try it on your own without listening to me, okay? Throw in a bridge, cross your units opposite. So I've got mole of FeOH3. Okay, so I know I want to plot it out first. So I'm going to look at my map, see where am I starting, where am I ending. Now I'm starting with FeOH3, but I'm ending with grams of water. Okay, so let's plot it. Let's see where we are. So I'm starting here at moles. And I want to get to grams of H2O. I want to get to grams of H2O. So tell me, if I'm starting here, I want to get here. Where do I go first? Go over the bridge. And once I go over the bridge, then what? Then go to grams. Do not go to grams yet. I'm starting here. So the mistake that people will make is they'll go this way. You're not going this way. You're going this way and then back down. Okay? You will have this for the quiz, by the way, the double mole roadmap. You'll be able to use that. I call it the switch it thing too. Okay, so I said we were going mole to mole first. I'm switching over to the other substance, which is H2O. So let's take a look at our balanced equation. Again, I need the coefficients in order to figure this one out. It looks like I have H2O on top and FeOH3 on the bottom. On the count of 3, what are my numbers? 1, 2, 3. 3 over 2. It is the same order as the last time, but it's not in the same spot, right? Okay, my mole of FeOH3 is gone, and now I'm in mole of H2O. I don't want that. I want grams of H2O. Cross opposite. Mole of H2O. Again, opposite means diagonal, okay? Opposite means diagonal. And now I'm just going to grams of H2O. Okay, what number goes with the gram in this case? 18.0. So the 18.0 goes here. So what number goes with the mole? 1. Mistakes. Mistakes. People will look back at the balanced equation and they'll say a 3 goes with the H2O. Wrong. This is an equality. This is telling us how many grams of water are equal to 1 mole, and that comes straight from the periodic table. So I'm going to show you that in just a second. Okay, so what is this equal to? So now all I'm going to do is multiply and then divide. And so if I multiply everything on top, leave out the 1, multiply 2.71 times 3 times 18, divided by the 2. Again, we can leave out the 1. And I'm getting 73.17. How would we round that? That would be 73.2. Very good. And that's grams of H2O. Okay, last thing I wanted to show you. I meant to show you this in part 1, so I'm just going to show you something real quick here. And the last thing that I wanted to show you is I want to show you what a mole looks like, okay? So this is the last part on here. And so if we look at, before you do your oils, if I look at a mole of different substances, for example, this is a mole of water, this is a mole of NaCl, of salt, this is a mole of sugar, this is a mole of copper sulfate, and this is a mole of sulfur, okay? If you look at them, they all look very different from each other. And it's like, well, what do they have in common? Really not much. It's almost like saying if you had a dozen eggs, a dozen cars, and a dozen pencils, what do they have in common, everybody? That you have 12 of them. There's really nothing else that they have in common, right? So it's the same thing here. If I have a mole of water, the only thing that's the same is how many particles. On the count of 3, what did we say the number of particles is? 1, 2, 3? It's 6.02 times 10 to the 23rd. Everybody, what is that number? 6.02 times 10 to the 23rd. That's how many of these I have inside here. And the way that I weighed these out is simply by adding up the numbers from the periodic table. So if I wanted sugar, now sugar's formula is actually C12H22O11. I would have to multiply 12 carbons, okay? So C12H22, 22 hydrogens, and then 11 oxygens, and that's how I figured out the mass of this. It ends up being something like 342.22 grams for 1 mole. Sulfur, on the other hand, is just one element. And if we take a look at the periodic table for sulfur, for example, let's come back down here, and let's look at the periodic table. If we look at sulfur's molar mass says 32.065 right here. So that's how many grams I put in here. So I created these mole bottles, these mole jars, on my own. So that's basically how you figure that out. Waters, we had already added up. We said water was H2O. So this is 18 grams for water, and water's density is 1, so I actually used 18 milliliters. So a milliliter and a gram are the same for water. It doesn't usually work for other substances. So just wanted to make sure you could see what a mole actually looks like. We can see a mole of like these substances. Why? Because atoms and molecules are so what? They're so very small that to have 6.02 times 10 to the 23rd is what I have inside of here, of them, okay? So just to kind of give you an idea, yes, that number is really big, but if I have things that are really small, then it works. I can actually see it, okay? All right, I hope this lesson was good for you. Happy day, everybody.